first conference talk ever, so if I am a little nervous, I'm sorry. But the talk is about the subtle art of debugging. I wanted to do a talk on a sort of non-technical topic, just to challenge myself, because I'm quite comfortable giving any kind of lecture or speech about technical subject that I'm aware of. And this is something I have been dealing with myself in my daily job, but I've never taught it or anything. So I'm trying to give you an overview of, well, the things that I learned over the years, and not necessarily in a technical sense. So we'll see. This is where I work currently. So a bit about me. I'm a software architect for one of a kind, wearing computer vision, everything related to cameras or algorithms based on images. I've been serving on SG14 for some definition of the word serving. I've been listening in mainly, and I've been on the program committee 2018 for cppcon. I have a blog you can go to, and I'm a contributor to cppspice occasionally, and hope to be a very active contributor in the recent future, hopefully in the coming future. So why are we even talking about this? I wrote a couple of things. You can read the slides, because it's really obvious, right? You just see a problem, you know what code is running, you have a mental model of what it's supposed to be doing, and you know you have mental modeling of what it's currently doing, and you know what it's supposed to be doing. So no problem. But what if you don't know all of these things? If you add asynchronous processing into the mix, if you have a distributed network, external factors to consider, multiple project versions, or multiple platforms, multiple compilers, things seem to get more interesting if you put all these things in the mix. And this is what I encounter at work sometimes, not a current job, but previous jobs, that people seem to have an attitude of not caring so much of what they write. And this is a book. I have not read it. I found the title very funny. And the picture also. So imagine this is our software, and she doesn't seem to be that worried about it. So what do we do typically? We write some software, it's running, problem gets reported. We have this great solution. Developer springs into action and assumes immediately, oh, sorry, I've completely understood your problem, I will fix it. Patch it, ship it, test it, ship it, wait for the next problem to come in because, well, it will, and then repeat. That's a fairly typical process that I see a lot. So how to get rid of that endless loop of debugging or problems coming in? I would say the first thing you do is you get a problem, sit down, relax, contact the reporter if you can, and see if you first can mitigate the human problem. So there's apparently someone using your software that has a serious issue with it and took the opportunity, took the time to report it. So obviously he cares, otherwise it wouldn't be reported. And it's important to him, otherwise he would have just ignored the problem and continued. So find out how urgent it is and decide on a course of action. And even if it's not urgent, collect information anyway, because there's no better point in time than when it's on the top of the reporter's list to get this solved and get more information. If you ask for this information a couple of months later, he will either not even remember reporting it, any logs will be gone, will not remember where the problem started or what he was doing when it happened. So it's very important to even if you determine not to do anything about it, to collect this information and store it somewhere, ideally in some kind of issue tracker. Then when you go talking to people, my experience is that there are a couple of kinds of people that you encounter. And this is not about a type of person, but it is, well, in general, people taking things that were obviously well intended, such as this advice from anyone knows that debugging is twice as hard. It's the intended, how I read that is, don't try to be too smart. Just keep it simple, and then it will be easier for you, because you will need that brain capacity when you debug it. But people turn it into, well, this person wrote this, so he's not qualified to debug it because, well, you need to be twice as smart to debug it. That doesn't help at all. It's just an empty phrase, and also things that you can encounter is, well, it can, I reported a bug, but it can be this because I already ruled that out for you, and it can be that. Yeah, that's nice, and these people can be right, but you have to verify it anyway. I'll come back to that later. So also doesn't help. Well, it was Tuesday, the sun was shining, and it was actually 2 in the afternoon when it happened. So that might be part of the problem. It could be true, but it doesn't help me because I have to check it, and I have to check all the possibilities anyway. I will also come back to that. What I find some programmers doing, sometimes myself, have a way of thinking that just gets me in thinking yourself into a corner, basically. So finding excuses not to think is, what I mean is, well, I checked this and I checked that, and both of them were not it. So there's nothing left. It's just a problem, and I cannot see a solution. So, yeah, nothing I could do about it. Close works as implemented, right? And that is not a good way to solve a problem. That will get you maybe you get paid per issue, and that will get you your money, but it will not solve a problem. Advice is like, I've been given advice from colleagues, good people, that say, don't touch that code because it's nobody touches that code, and it's just so old you don't want to go there. Yeah, that's nice, but if there's a problem in there and the customer needs it fixed, you have to touch it anyway. Working around it will make it probably even worse. If you don't understand a piece of code and you work around it without understanding it, that will not make it better. You will fail in that case. The other things are just varieties on the same theme. So it's legacy, so it's bad. That doesn't help. It is an empty statement again, and legacy is not per se bad. It's the not invented here syndrome, but then considering stuff from the past instead of other people. Copy pasting, of course, is a great source of interesting bugs. This, and this is the ultimate hiding place for bugs. If you have at least maybe not an embedded, but in exception-based systems, this gets rid of any exception, and your predecessor will have a great time finding this bug that you hit here. So other kind of people that you can encounter is what I call the local hero. It's a person that has been there for years, knows everything about his existing environment, system, and all the systems that came before. Maybe he's working there for 30 years. These persons have strong opinions about how things should work, or how good previous systems worked, and that we should revert back to that way. Or they have a certain intuition. Well, if this is the problem, this is how you fix it, always works. And the problem is they're often right. And that can be a blessing or a curse, because with this being right, they have earned respect of their colleagues, and fairly so. But you can also, so it can be a cumbersome person to work with, because they have very strong opinions and just can wipe your arguments off the map, saying, well, I want to investigate this part. He says, no, don't waste your time. I've seen it. I've done it. It's not there. But it can be. We haven't ruled it out. He has ruled it out with, and I don't know based on what rationale. So it can be a cumbersome person, also can be a very helpful person, because he has, as I said, he earned the respect, so he can say, no problem, this software engineer here is solving the problem, no worries, it will be solved. So you can have either be bothered by this kind of people, but you can also use them in an existing organization and say, okay, please give me some space and help me calm the situation down. Helps you again to relax, get a drink, and continue. Why do problems not always reproduce? The bug report can be wrong. Our understanding of the expected behavior can be wrong. So maybe it's doing exactly what we wanted it to do, but the expectation was different. So then you get a bug report that's actually saying, well, the code is not doing what I wanted to do, but it's doing exactly what I told it to do. And I can say, okay, that's a false bug report, but there's still a person with a problem. So it happens. Bug reports, of course, false positives happen, false reports happen, but often there is some problem that you can solve for this person, and it's worth taking a look into. Other problems or aspects of not being able to reproduce, well, race conditions, we all know of them. External systems, environmental conditions, like external systems can be servers, any external hardware that you have outside your machine. Environmental conditions, so different hardware, different target, new temperature, load sometimes. That can have latency problems with load. Certainly, well, depending on what system the kind of system you have, can be seriously annoying. Time zones, I've seen too many problems with time zones. Also, wrong observation. So either by us of the, so what's this? Can anybody say what's that? What is that? Very good. It's actually a wallet in the shape of a floppy disk. So, yeah, obvious observations can be very wrong very easily. How do you find a problem? I tried to come up with 4 P's, but I had to go with 3 P's and an I. So, how do you get the root cause of a problem? I thought about this, and I think the most important skill that I use is partitioning. So you have some problem space, you basically have an idea of where it could be, and you try to divide that up as good as you can in different, either software versus hardware, components, time. You find something to partition and partition it and start ruling things out. It's completely obvious to some people, but there are many people that focus on, that pick one, focus completely on that one thing and try to find a bug in there. It must be there. Oh, well, you haven't ruled all the other things out, so why assume that it's in a certain place? I have more slides. I shouldn't. Yeah. So partitioning, I would say hypothesize about. You can pick one section, hypothesize on what the problem could be, and try to disprove it. But it can be either very effective if you're right, or it can be very tiresome if you have to do linear search basically to your whole problem space. So in general, you can try the first thing a couple of times, and then you just have to start bisecting your problem space and say, okay, no more guessing. We're just gonna systematically rule stuff out. And then you find another, so what focus? When you find a problem, it's not the exact same problem that you're searching for. You found a problem. Think, oh, it's obviously a if statement with a null pointer, and in this case it will crash. That's obviously a bug. Don't fix it. Or determine that it is, don't fix it right. Either report it as a bug, and then decide we're going to continue with ignoring this thing you found, or fix it first. But in that case, revert all the work that you did, just fix one thing, test it, and then continue the other work. Because if you let yourself get distracted and fix that other thing, that might have side effects that influence your original problem. And all of the work with the bisecting that you did, you have to do it all over again because it could be different now. Healthy dose of paranoia would also be helpful. So people, I don't mean harmful lies. People just observe and tell you what they saw. But it might not be the truth. It must just their observation. So it's helpful to say, okay, tell me all the things that you saw, but you have to verify each of those statements anyway. Debuggers lie. They do. I have an example. A very simplified. So this was not supposed to be a technical talk, but I couldn't help myself and put Godbolt in here because otherwise it would not be a proper presentation without some Godbolt in there. So this is a very simplified thing that I found in an existing code base. Here we do get env. So if an environment variable exists that's called foo, we call one, and one calls modify that is defined as extern with the parameter 1, argument 1. Otherwise 2 is called. So far, no surprises. You can see that the code is optimized, and there's no longer any, well, right now it's not optimized because the modify is external, so nothing can be optimized. You can see there the modify function is always called. But if you make this function static, of course, then everything can be, nobody can call it from the outside. The modify method doesn't have to be visible anymore. And I put some print statement in there because otherwise it would completely be optimized away. And but what you can see now is that there's no longer any symbol information for the debugger for call 1 and 2. Now this is a very simple example, but if the call stack is much deeper, you might be surprised that modify is called from main, and when you look into main, it's never called. And this is, let's say, very obvious if you have small functions and see, well, main only calls call 1, so I just look there and that's where modify is called. But if you have a legacy code base with, let's say, 5,000 line functions, that's hard to see. And the debugger is not actually lying, it just doesn't have that information anymore. And it's helpful sometimes to keep that in the back of your mind. Okay, I'm seeing this weird call stack, I don't understand it, but let's continue anyway and see how that relationship came to be. So while I was making this example, I found an interesting thing here. I was playing around with it, and in the third case here, when I removed the side effect of printf, it's completely optimized away. And I thought, oh yeah, obviously I have to put a print statement in there. But actually, there's a getEnv here. How does the compiler know that has no side effects? So apparently, I ran into an interesting optimization where the compiler has a list of functions, I think, that it knows has no side effects, so can be not called if it's desirable. Otherwise, it could not optimize this away. Just an interesting side effect. So if anybody knows the answer to that, I would be grateful. Asynchronously. Asynchronously? Is it the? Multi-threaded code is in general more susceptible to multi-threaded or maybe on embedded, more event-driven code, more susceptible to race conditions than single-threaded code, obviously. But also they tend to interact with external systems, and the interesting thing is that the causal relationship between things tends to get lost. If you have the single-thread application, you have some call with an effect that you can immediately observe. But if it's an event-driven system, the cause and effect things are not always easy to track. So I will give you an example quickly. So how to, in that case, or in any other case, how to collect more data, how to look for the problem, let's say, in time, or how to collect more data. And there's obvious tools. You have to find the right tool for the job. But we all have the famous, I'll use the famous printf, and very helpful tool sometimes. You can use a debugger, whatever you want. I make this, I use a lot of log statements myself. I like them. And I distinguish between log statements and telemetry. And my for this talk, I will define telemetry as structured logging without text-based storage. So there is some kind of instrumentation that's always in your code that's collecting data points that are consistently stored in a binary storage, and it might be cyclic, they might be stored forever, depending on your system. But the difference between the two, for me, is that log statements are costly and verbose, and telemetry is not. It's supposed to be at the cost level you can afford, giving you the information that you need, which is of course a very general statement and not always easy to quantify what that is. But it depends on your need and system. So I can compare finding the right tool with electronics and saying, okay, so for some things an oscilloscope is really helpful. If you know some event is about to trigger and you want to see what happens after that event, then an oscilloscope is nice. But if you have sequences of bits being transmitted, yeah, it's not that nice anymore because it will not fit on the screen, or there's other limitations, or it doesn't have enough memory. So you pull out a data logger and do some analysis on that, or different. I'm not an electronics guy, so I just put data log. I don't know what it is. So, but the point is, you need a different kind of device. So the same thing goes for me for these other. I see these log statements and output telemetry as requiring different tools. This is a tool called Debug Few that I've written. It's open source. It's Windows only. Doesn't mean it cannot be used for embedded, because I've used it for debugging Android devices and ARM processors, just experimental boards. Just dump whatever's coming in over the serial port into into the standard in of this tool, and it will just display fine. The point here is there's stuff happening, and there's obviously some pattern. I've highlighted that some repeating pattern is happening here. But if there's something that's happening with a low frequency that doesn't fit on the screen, becomes really hard to see. So for that kind of thing, I think it would be helpful if you can have this kind of view. And tools like this exist. I've just not found the right one for me yet, I guess. And I think, oh, that's one too far. So if you have a start at the green line on the top and a stop, so that's the start of a process, the green line. Start, it says unit test start. And then here, apparently there's in progress, and sometime later it stops. I don't know if it's even logged. But there's progress here, 1, and progress 2. So if you have this view, and these would be the same data points, you can really easily see that in the first test, 4 things happen. In the second test, nothing happens. And there's actually an outlier here that's apparently doing something in between tests that nothing is supposed to happen there. This was not obvious from the log file at all. You cannot see that here because it's just a bunch of random log statements. But in this view, you can easily see that's a very odd thing that's happening there. So, what to do when you run into this? You have this problem and you just don't know anymore. Happens to me all the time. So I've tried all this and I just I'm tired. I've searched for hours and I'm not sure what to do yet. So I cannot say this enough. Take a break. Relax. Stay hydrated. Rubber duck it. Tell somebody what you did, what steps were involved, why it didn't work. And if one person is not enough, get more people involved. Sometimes you have to you just pick a few people that you think might have completely different insights than you, or have different background than you. They come up with interesting things, such as instead of collecting this kind of data, what about this blinking light here? It's always red. Why? That's normally not true. I didn't even look at that. I didn't look at that. So yeah, people make excellent ducks. You can just talk to them, and sometimes, a lot of times, when you actually spell out your own process to someone else, you will find the flaws in your own reasoning. And it's actually nicely stated in this quote. The best way to understand something is to explain it to someone else. Before, if you found it, you found your problem now, and now you're done, right? We could just fix it and done. Actually, I think there's more to it than that. You should consider the impact of your change. In what software version do you want that to happen? Do you need to provide a patch, or just can you just commit it on the head branch? Do you want to keep it for later? I don't know how many times this happens to you, but to me, a lot of people think, I will fix this problem right now, because it's 2 minutes work, commit, push, ready. It's not been tested, it has not seen production, we were just about to release, nobody asked for this. It's just, think about what you're doing, think about the impact of your, and if nothing else, think about the test impact that what would have to be retested if you change this line of code. If there's some low-level component, basically everything would have to be retested to make sure that it has no side effects. So that, yeah. And of course, create a failing test before fixing. Actually, myself, I tend to fix it first, and then revert it, create a test. I have to force myself to obey that rule, because I'm very anxious to see if I was right in did I actually now find the problem, or was it something else? But I think it's still valuable. If you can observe the behavior, you could probably make a test to show that something goes wrong. And sometimes that's much easier once you know what the problem is. The danger is then you're writing a test to test what you're actually going to fix instead of the observed problem. And that's sometimes not the same thing. Okay, so bug fixed, right? Done. Right, wrong, because as a responsible software engineer, you're supposed to check, was this code that I fixed ever copy-pasted somewhere else? And should I fix the same problem in maybe a different branch? Or again, consider side effects. So who do you have to notify if this is changed and you determined, excuse me, it should change now. It's critical that it changes now because maybe it was undefined behavior and it has to be fixed right now. But then you have to inform some people. So okay, you know this critical thing that I fixed, you should really test that. Sometimes you have to, yeah, of course, as a software engineer, you test your own work first. But if you work at scale, there are often test people involved, PQA people involved. So make sure they know what actually changed. What I see happening a lot is that the reverse process is followed. So people make all kinds of changes, and then some really good PQA guys comes along and say, okay, give me the commit log, and I will figure out what to retest. But that's error prone. You should just make a list of, okay, now I've touched this component. Okay, touch the same component again. No problem. It was already on the list. But if you collect this list over time, it's much less likely that you're missing something than when someone is scrolling down on a commit list that doesn't have and also doesn't have the insight to judge, is that a local thing? Will it be good enough to just test this component, or should I test the whole because it will have visible outside behavior changes? Finally, you fixed it. The bug is solved. But how did you get there? So what's often forgotten and very valuable, I think, is to describe what you actually did to fix it and why you fixed it that way. Because sometimes there was some use case, an edge case that you missed, and there will be a new bug report that's unavoidable sometimes. And then it's really helpful that you can see, okay, the last person that worked on this fixed this for this reason, because he observed this behavior, and then you can verify that. Okay, it seemed the same thing, but he missed this, or he missed this side effect. Okay, so now I understand the change so far, because very often you don't have this. You look at the code and you can look at the commit log and you say, well, I can see that something changed. The comment was bug fixed, but I don't know why this change fixes that bug. There's no obvious relationship. So really helpful to document that. So that was actually all I had. So takeaways: keep hydrated, mitigate. So try to solve the human problem first. Decide on the course of action. Is it actually urgent? Should you work on it now or keep it for later? Keep partitioning. Don't stop partitioning. Have a healthy paranoia and find the right tool for the job. And finally, document your fix by making a test. These are some links. The top is Debug Few++. It is, I consider it stable. Matter of debate sometimes. DebugVisualiser is a new project I'm working on. I'm trying to collect all the requirements for to have a tool looks like this, but then allows you to say, this is where my process starts and this is where it ends. So get me a diagram to just, from this log file, create me a picture. And maybe it exists already and someone can tell me, don't bother, exists, problem solved. I would be very happy if I had a tool like that. If not, then maybe you can contribute some ideas on this. This is now an empty GitHub project where I collect requirements and possible libraries, such as CopperSpice, where I can what I can build it on. If you want to follow me, I have a website called nullpointer.nl, and I'm on Twitter and Slack. That's all I have. Thank you very much.